So, we are going to study metric space. So, let me first define a metric space. So, what is the definition of a metric space? A metric space is a set X with a metric D. So, D is representing a metric. It is also called distance function. Defined on it. Where the metric D satisfies the following. So, these are actually the axioms which need to be satisfied by the metric. The first is it is real, non-negative. So, this metric is actually a function from x cross x to real numbers. So, it will take two elements and will give you some real number, and non-negative is also finite. The second property that it needs to satisfy is this, that if dxy is 0, so then it implies that x is equal to y, and the converse is also true. If x is equal to y, then dxy will be equal to 0. And the third property is that dxy is equal to dyx, and the fourth axiom is that if we have 3 points x, y, z, then the distance from x to z is less than or equal to distance from x to y plus the distance from y to z, and this is known as triangular inequality. So, these are the typical properties of a distance function. For example, the distance is always a real number, and it cannot be less than 0, and it is finite. And similarly, if the distance of a point from the same point is always 0, so this becomes the second axiom. And similarly, so this one is the real one. The distance from x to y must be equal to the distance from y to x, so that is also obvious. And this one is the triangular inequality. So, if you have 3 points, for example, if you have, let me say, x, here is y, and here is z. So, this distance is actually dxz, and this is dxy, and this one is dyz. So, this will obey the triangular inequality. So, now if we have some set x and we have some metric defined on this, so then this combination or this pair will form a metric space. So, we must remember that there can be many metric spaces on the same set. For example, you can have a set X, and then can be D1, one type of metric, there can be another type of metric on the same set, there can be another type of matrix on the same set. So, we can have various matrices on the same set. So, then the metric spaces will be different. For example, this space will be different from this space. This will be a different space, this will be a different space, because they have distance functions which are different. So, let me give some examples of the metric space. So, the first example is that of the real line, and we have some metric on this, and the metric is, if we have 2 points x y, so it is the absolute value of x minus y. So, obviously this is a metric. It is just the magnitude of the difference between 2 points. For example, if we have 5 minus 3, so this will become 2. So, let me verify whether it really forms a metric. So, you can easily see that dxx is 0, similarly dxy is equal to dyx. You can verify this because x minus y is equal to y minus x. So, this is verified, this is verified, and the first axiom is also verified because it is always non-negative number and real number, and the triangular inequality is also obeyed here. So, this is quite obvious. The second example of this is, if you consider the Euclidean plane R2, Euclidean plane. So, in this case what will happen? So, let me say if we have 2 points in the Euclidean plane P1, which has coordinates x1 y1, and P2 which has coordinates x2 y2. So, I can make a metric space in this manner R2D, where D between 2 points will be defined in this manner. This will be x2 minus x1 square plus y2 minus y1 square root. So, this defines a metric space. So, this will be, we can easily verify that for the same points in the set of Euclidean plane, this will be always 0. Similarly, this also commutative, and this also obeys the triangular inequality. So, this is R2 D is a metric space. Okay. So, on the same set I can also define another metric in this manner. Let me call this D1. So, let me make it in different color. So, we can have another metric on the same space, and that is D1 is, let me say, in this manner. The inputs are actually 2 points P1 and P2. So, this will become x2 minus x1 absolute value plus y2 minus y1 absolute value. So, this also defines a metric. So, we can easily verify this, because if we take the same point, so then this will become, obviously this will become 0. Because then this x1 will become equal to x1 and y1 will become equal to y1, and similarly dp1 p2 is same as dp2 p1, and similarly triangular inequality is also obeyed. So all the properties of a metric are obeyed. So this R2D1, this is actually a different type of metric space. So the set is same, but the metric space is actually different. Okay, so we stop here, and hopefully you have enjoyed this video, and please subscribe the channel for more videos.